Now, welcome back to the satellite communication. We say that we have a satellite orbit. That is about the satellite orbit. So here the Earth is there. Earth has the gravitational force. So because of that gravitational force, that satellite will continuously falling on the Earth. So but we need to be one more force is to be there. So that's why that force it will keep away that satellite, or because of that it will rotate in this given orbit. So some force will be there, and that force is called as a centrifugal force. Means because of that gravitational force, satellite will pull. Okay, here it will pull by this Earth there. Means because of that gravitational force, it will continuously pulling by this Earth there. And then when we pull the satellite, that because of that gravitational force, but the satellite is to be continuously swing or continuously move around the Earth. So in that case, we can say that this particular object, they have some motion. Okay, they have some motion, and that motion of this particular object, it changes. Okay, that motion is there. That particular object has a circular motion there. Because of that particular force, that velocity of this particular object to move in this particular orbit, it is to be changed continuously. Okay, because of this particular force. And that change in that velocity is not due to the whatever the magnitude. Okay, that change, whatever we can say that change in the velocity is not due to the particular magnitude, but because of that particular force. But or you can say that that satellite, it changes their direction. Okay, because the satellite it changes that direction. So this change in the velocity, that change in the velocity gives the acceleration. Okay, the change in the velocity gives the acceleration to the object. Okay, the change in the whatever we can say that is about it, velocity. Okay, by this particular object, because it is we say it is about rotating around the earth. So change in the velocity gives the acceleration, and that acceleration, that towards that acceleration, or you can say that velocity the direction that will be toward the earth there. Okay, that will be towards the earth. Now based on this particular fact of motion of this particular uh, object around the earth, so it has some particular force that will move towards the earth, and when it will rotating in that particular object because of that circular motion, it will be move away from this particular object. That is called as a centrifugal force. And this is about the gravitational force, centripetal force, and centrifugal force. So we say that if supposed to be there is the absence of this gravitational force of the earth, okay, if there is a that absence of the gravitational force, what will happen? So it will be rotating around the earth as per the whatever the force there. Okay, so there is no pulling. Okay, or even in generally you see that when it is rotating, so sometimes what happens because of that motion, so it will be move towards or move away from this particular that particular orbit there because of that motion there. So we should know that based on this particular motion of the object, so we should know some laws. That laws we say that is about the Newton law. Okay, so we say that about the law is about the Newton law. That Newton law of So you say motion. Okay, so that is about a Newton law of a motion here. So what are the Newton law of a motion? You know that all these Newton laws earlier. Okay, first law is what? That it says that a at a rest, body at a rest, it is to be erased. Okay, body at a rest continues to be at a rest, and if in motion continue to move at the same speed in the same direction, unless an external force is applied. Okay, unless an external force applied. So this law is known as a law of inertia. Then a second law, that is about, we can say that is about a law of inertia. Then second law we say that is about the a force acting on a body introduces acceleration in the body. Force acting on a body introduces acceleration, because why acceleration? Because of the velocity, change in velocity. Because body's velocity will be changes in the body whose magnitude, okay, whose magnitude is proportional to the force and the direction of force. Okay, that is nothing but what? Force acting on any body. Just like when we say that force acting on the body, it changes, it introduces acceleration in the body, means it moves, moving. Okay, whose magnitude, that is about force, whatever we can say, that is proportional to the force and in the direction of the force. Then a third law. Third law is what? Action and reaction are equal in magnitude and opposite in a direction. Action and a reaction. That action and reaction are equal in a magnitude but in opposite in a direction. Just like if you say that we have seen the example earlier for the pendulum and all. Okay, while people have learned that particular Newton law at that time in physics. Now, these particular laws of inertia, that force, that action and reaction, all these laws are applicable to this satellite there. Okay, so now if, because we can say that a satellite is moving around this earth there, so it has some because this earth is having a gravitational force, that because of that gravitational force, that satellite will pulling toward the earth there. Okay, pulling toward the earth because of that gravitational. In that case, if the satellite mass, the mass of a satellite, okay, if we consider that a mass of a satellite is to be assumed m, and because of that acceleration that we consider that is about a, then the force acting on the satellite, that force acting on the satellite, that will be obtained from the, yes, with, that is the second law, that will be equal to the mass and the acceleration. Okay, you can say that is about a F is equal to ma. So in that case, what we say, it is about the second law, second law of a Newton law. So we can say that F is equal to ma. And in that case, we say here F is equal to ma. And if we consider that the velocity, if the velocity of a satellite, okay, is v, then the acceleration a is nothing but what? V square by r. Now in this case, r is to be considered here. R will be a orbit radius. Okay, r is to be considered as a orbit radius. So a is equal to That is about the acceleration there. And so this about the orbit radius, how we can calculate? That will be from the distance of the, that will be orbit is nothing but what? A distance. And that distance from the center. Okay, that is what we can say, that is from the center of the earth. Okay, this is from the center, not the surface of the earth. From the center of the earth to the satellite. Okay, this is nothing but the radius. That is called as a distance from the center of the earth. Okay, center of the earth to the satellite. Okay, that is nothing but a, what we can say, a r. That is about the orbit radius. So we can rewrite the equation f again. That f is equal to what? M v square by r. Now, as per the Newton's law of gravitation, the force of attraction between the bodies, that will be directly proportional to the product of their mass. So in this case, we have the two objects. That is about, we can say that is about the Earth, and we can say that is about the satellite here. So in that case, we say that that is the force of attraction between the two bodies is directly proportional to the product of their mass, and that will be inversely proportional to the square of the distance between them. So that according to the Newton law of gravitation, F is equal to what? Is equal to G into M1 M2 by R square. And that G is equal to gravitational constant. Okay, that G is nothing but a gravitational constant. Now this M1 and M2, here we say that a M1 and M2, and that will be nothing but what we say, M1 and M2 is nothing but what? A mass of the whatever the object, or with whatever the two bodies here. Okay, so mass. Because now this is supposed to be equation, if we consider that in the case of what? A satellite, or in the case of a, if we write the equation, same equation for the satellite and same equation for the earth there, in that case we write m1 is to be replaced with m1 will be replaced with m, that is the mass of satellite, and then m2 will be replaced with a capital M, and that will be the mass of the earth. And then if we rewrite again this equation, this is about the equation, if we rewrite again the equation f, that f is equal to, that is the gravitational constant, that is small m, is capital M divided by r square. Now as we know that the mass of the earth is a constant, that is mass of the earth is a constant, it is about what we can say, that is a 5.9758 into 10 to the power 24 kg. And the universal gravitational constant, that is the G is equal to 6.672 into 10 to the power minus 11. Okay, so we can write in a different way also. Okay, per kg s square. Okay, so you can write with a different ways and all. So now these are the forces, that is about the based on this particular mass, and one is about because of that acceleration. These are the two equations. one equation is about mv square by r, that's about because of that acceleration, and another is about the because of that mass. These two forces that will be acting on the satellite that are called as the centrifugal force. Okay, so we can say that, so we have the because of that velocity centrifugal force, or you can say that is about a gravitational force. Because of what that particular force, centrifugal force means that will be move away the satellite from this given orbit, or you can say that, so it will that satellite will move away from this particular orbit, or we can say that that is a outward direction. Okay, outward direction. So you might have seen on the road. Okay, when we have a straight road there, abruptly supposed to be some turn comes. So when you move your vehicle, so what happen? It will looks like that vehicle will move away. Okay, move outward direction. Okay, move. It looks like a vehicle will move outward in that particular because of that circular motion, and that force is called as a centrifugal force. It will be outward force. So that's why if you see that whenever we have a corner at that particular place, that road's position is just slanting here. It looks like a slanting here, so that it will not allow you move away from this particular place. Okay, you can try it. Don't try with a high speed. Now we say that that will be moved outward there, and that will be that force is depending upon that what will be the velocity of this particular object. So we can see here this equation because of that velocity. Here we say that is about it. This we can consider that is about a centrifugal force, and because of that gravitational, we can consider this force is about a gravitational force. Okay, so you can say that is about a centrifugal force, or we can write here a centrifugal force. Okay, is equal to a gravitational force, and that centrifugal force is nothing but what? It is about a m v square by r, and gravitational force, you know that that is the mass of the satellite and a mass of this object by r square. Okay, that is about a centrifugal force. And if you solve it, okay, if you simplify here, that is r only, m get cancelled here. We'll get that by solving in terms of velocity, we can calculate that that is v is equal to gm by r. Okay, v is equal to gm by r. So this is about our velocity of a satellite, or you can say that velocity here of a satellite, or we can say that is about the object. Okay, this is about a velocity of a satellite or a object. But we know that the product of what, that is gravitational force and that mass. Okay, this gm, and that is called as a gravitational constant. This is called as a gravitational constant, or we can say that it is about a Kepler constant. So we can say that the values for this gm is equal to mu 3.986 into 10 to the power 5 kilometer cube by s square. So we can rewrite the equation again. This is about a v. We can rewrite the equation again. So that equation we can say that v is equal to under root of mu by r. Okay, this is nothing but a v is equal to under root of mu by r. So, so that is about the equation of a velocity, and that will help us to obtain the what will be the satellite distance from the center of the earth, or we can find out what will be the orbit velocity. So this is about a satellite orbit and Newton's law.